Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure this book is in front of you when you're working with me. Today is our day number 8. And we'll start with problem number 52, the very first problem on the page. As you can see, the problem is already on the blackboard. I'm going to read the problem to you and then I'm going to get out of your way. I want you to pause the video and do the problem yourself first and then compare your work against the work that we'll do together. Do you understand? So here we go. We are told that we have two integers, x and y. X and y, we are told, are two positive two-digit integers. They are both two-digit integers. They are both positive. They have the same digits but in reverse order. In other words, if one is 15, the other one is 51. The question simply is, if that's true, then which must be the factor of their sum? Which must be the factor of their sum, x and y? 6, 9, 10, 11, or 14. Do it yourself. Well, the quickest, the simplest, the most efficient way to do this kind of problem, as I have told you many times before, is to plug in numbers. Simple numbers, plug in simple numbers. The smaller the numbers, the quicker the work is going to be. I'm going to plug in 12, and let's just see what happens. If we plug in 12, if we pretend that x is 12, if we pretend that x is 12, then y must be 21. And let's just see what happens. If that's the case, then the sum of x and y is 33. 33 is simply 3 times 11. Is 6 a factor of 33? The answer is no. The factors of 33 are 3 and 11, which means anything, if it has 3 it works, it has 11 it works. 33, 6 is not a factor of 33, 9 is not a factor of 33, nor is 10, nor is 14. There we go, we got the answer. The answer is 11. And if you like, if you don't believe me, you can try one more time. You can try 20 more times if you want. Let's try one more time. What number should we try now? I'm going to try 52. Why 52? Because it's a problem number 52. Even though 52 is a very large number, but just for the hell of it, let's try 52. 52 plus 25. What do you suppose is going to happen? 77. It's a multiple of 7 and 11. We don't have 7 here. We only have 11. 11 is the answer. Now very quickly, just to satisfy your curiosity, as far as the exam is concerned, as far as the GMAT is concerned, if you were taking the real GMAT right now, you will take your loot, you will collect your loot and run. But just to satisfy your curiosity, we're going to do it algebraically. Something that you will not do in a real exam. Just do it algebraically. In order for us to do it algebraically, we have to first understand how to represent a two-digit number algebraically. For example, if I have 27, then x is 2 and y is 7. How do I represent algebraically? X is a 10 digit, which means it's going to be 10 times x plus y. As you can see, 10 times x, 10 times 2, because it's a tenth digit, not th, tens with the s, is a tenth digit. So it's 10 times 2, which is 20, plus y, which is 7. There you go, that's how you represent 27. And how would you represent 72? Well, now our y, this is our y and this is our x. So it's going to be 10 times y plus the x. And if you take their sum, what do you suppose you're going to find? You will find 10y plus y, that's 11y, and 10x plus x, which is 11x. As you can clearly see, x comes out common, and the sum is simply 11 times that amount. The sum of the two digits, sum of these two digits is simply 11 times, or rather the sum of the two integers, is simply 11 times the sum of the digits. The question was, which of the following is the factor of the sum of these two integers? The answer is 11. It will always be 11 no matter what you try, as long as you try two different digits. They have to be two different digits in reverse order, a two-digit number. Number 53. We spent a lot of time on this question. and I don't like it. 53. We are told that we have a sequence of 8 consecutive integers, starting with -5. The question simply is, how many are positive? Don't be hasty. Don't be hasty. Don't be quick. Don't behave in the way that they expect you to behave. Don't just think that since we are starting with -5 and we have 8 of them, there must be 3 positive. Just write them out. Just play safe. Write them out. It only takes a few seconds. Starting with -5. -5, -4, -3, -2, -1, and then there is a 0. There is a 0. And then a +1 and a +2. That's going to give us 8 consecutive numbers starting with -5, out of which only 2 of them are positive. We mustn't forget the 0. We mustn't forget the 0. That's all it was in this problem. 54. Let's see what 54 has to say. '54 says that we have a total of S oranges to be packaged in boxes. We have certain quantity of oranges, we're going to put them in boxes. We are told that each box holds R oranges. We are further told that N boxes have already been packaged, they're already filled. The question is, what are the number of boxes that remain to be filled? One more time, we have total S oranges. We're going to package them in boxes. Each box we told holds R oranges. We have already filled up N boxes. How many more boxes to go? And our job is to give them the answer in an algebraic expression using this symbol S, R, and N. Go ahead, do it yourself. Well, plug in numbers. If it helps you, plug in numbers. For example, if we had 100 oranges, and if I tell you that each box holds 20 oranges, that makes life easier. Now we know that we need 5 boxes, which means this quantity, S over R, represents the total number of boxes we need, because we have 100 oranges, we are putting 20 in each. And if I further told you that we have already filled up 3 boxes, then we have 2 more boxes to go. Well, there you go. 100 over 100 over 20 is 5, minus N. Minus the 3. There is your answer. The question was, how many more boxes to go? The answer is S over R minus N. The total number of boxes that we need, which is going to be represented by S over R, total number of oranges we have, divided by how many we can hold in one box, minus the number of boxes that we already filled. Number 55. In number 55, we are told that A is greater than 0, which in turn, and B is greater than A, and C is greater than B. Question is, which must be true? And we have 3 statements. We're going to go through all 3 of them one by one. Here's the first statement. The first statement tells us that 2A is greater than B plus C. Greater than B plus C. Let's see if that's true. And again, You can do it algebraically, or you can just plug in numbers. Let's plug in numbers. Let's plug in 1, 2, and 3. What happens? Let's see what happens. B is 2, C is 3, and we are claiming that 2 times 1 is greater than 5. Of course it's a nonsense. Of course it's a nonsense. Another way we could show is that we know, let's do it algebraically. We know that A is less than B. We know that A is less than B. We also know that A is less than C. A is less than C. So if you were to add up two quantities, we'll end up with 2A would have to be less than B plus C. There is no way 2A can be greater. That is not true. The first statement is not true. Let's look at the second statement. Again, second statement, you do it yourself, okay? I didn't give you a chance to pause the video. You do it yourself. Second statement claims that C minus A is greater than B minus A. Go ahead, do it yourself. Alright? There is nothing to do here. Just add A to both sides. And what we end up claiming is that C is greater than B, which of course is true. C is greater than B. Second statement is true. No need to plug in numbers. Here is simpler to just do it algebraically because algebra is too simple. Number 3. Third statement claims that C over A is less than B over A. Go ahead, do it yourself. Okay, here we go. Since we are told that A is greater than 0, which means since A is positive, if we have inequalities, we cannot multiply by negative numbers, because if you multiply inequality by negative numbers, you know it changes the direction of the inequality. But A is positive, we are told. So why don't we just multiply both sides by A? And now we have to answer ourselves. Is C less than B? No, C is greater than B. That is not correct. Only the second statement was true. Only the second statement was true. That was number 55. Number 56. You know what? I'm going to leave 56 until the very end. Let's do 57 first. 57, we are told that the price is $2 per unit. We are told that the variable cost is 40% of price. Now, in the problem, it does not say it like that. It does not say that the variable cost is 40% of the price. What it says in the question is that the cost of producing each unit is 40%. In other words, every time you produce something, the cost of producing that unit is 40%, we're making 60% profit on it. Do you understand? The 60% of the price, rather, goes in our pocket. We're also told that we have a fixed cost. The fixed cost was $5,040. $5,040 is the fixed cost of each production run. The question is, what is our break-even point? How many units do we need to sell before we see any profit? Do it yourself. I'll give you a second to pause the video. Here we go then. The variable cost is 40% of the price, which is same as saying it is 0.4 times the P. And P, of course, is $2. So to find the break-even point, we need to equate the revenue with the cost. And cost is made up of fixed cost plus the variable cost. And the revenue that we're going to get is $2 per unit. And we're going to sell Q unit, Q for quantity. The fixed cost is $5,040. And the variable cost is 0.4 times P. We just have to solve this equation. I could continue here. There is not much to go here. I could continue here, but it's too low. So I'm going to continue on the top. It's very straightforward. 2Q, and here we have 0.4. If we subtract 0.4 from both sides, we're going to end up with 1.6Q equals 5040. Let's multiply both sides by 10. So 16Q will equal 5000. I'm going to multiply it by 100. I'm going to bring this zero with this guy. Let's see what we can do. We have to multiply, we have to divide. That is not what I have in the problem here. Oh! We have to just start again. I made a mistake. Let's start again. I made a huge mistake. The revenue has to equal fixed cost plus the variable cost. The fixed cost is 5040 and the variable cost is 40% of the price. 40% of the price times the quantity. I don't know what the hell I was doing. That's the variable cost. The variable cost is 40% of the price for each unit that we're producing, and we're producing Q units. The price is $2. The price is $2 times Q. Now it makes sense. And the revenue is simply 2 times Q. Because we're selling Q quantities each for $2. So that's the equation here. And this is 5040. 0.4 times 2 is 0.8. If you subtract 0.8 from both sides, we're going to end up with 1.2Q will have to equal 5040. Multiply both sides by 10. 12Q will end up equal 5004 times 100. Let's divide both sides by, I'm going to divide by 12. Let's divide both sides by 12. 50 is made up of 4 12. 4 12s are 48. 4 12s are 48. After we take away 48 from 50, after we take away 48 from the 50, we have a remainder of 2. 2 goes and joins the 4 and becomes the 24. And 24 is made up of 2 12s. There we go. Q must equal 4200. In other words, as soon as we make 4201st unit and when we sell it, that's when we see the profit. Up until now, we are just breaking even. We are breaking even though we're charging $2 for it, and we know that only 40% of that is the cost of producing that unit, but the remaining 60% is still going towards paying for the fixed cost. After 4,200 units, that's when we're going to begin to make a profit. Let's do number 56. And the fixed cost, in the problem, they go on to explain that the fixed cost is the cost of buying the machine. That's what the fixed cost was. 56. In 56, we have company A, Monday, Tuesday, Wednesday, and Thursday. We have 45, 55, 50, and 50. We have B, 10, 30, 30, and 10. We have C, 34, 28, 28, and 30. I want to make sure I don't make a mistake. D, 39, 42, 41, 38. Then we have E, 50, 60, 60, and 70. So here's what's going on. The question is, which data set has the greatest standard deviation? Which data set has the greatest standard deviation? There are 5 companies, A, B, C, D, E, and this is how many packages they have shipped in the 5 days. Company A, on Monday they shipped out 45 packages, on Tuesday they shipped out 55 packages, Wednesday 50, Thursday 50, and so on and so forth. This is the data for the 5 company. The question is, which of these 5 data set has the greatest standard deviation? I'm going to get out of your way now so you can get an unobstructed view of the blackboard. This time I insist that you pause the video and do it yourself. since we are looking for the greatest standard deviation, we're going to start with A, find out what the standard deviation works out to be for that guy, and then we're going to keep on going, and we're going to eliminate anything that is lower value than the one before, because we're looking for the greatest one. In order to find the standard deviation, we have to first find out the deviation from the mean. Each observation from the mean, deviation from the mean. And then we have to take the square of it. And then we have to take the sum. That's what we have to do. But before we do any of this thing, we have to first find out the average. The average of these four numbers is very simple. You take 5 from this guy and give it to this guy. Now they are all 50. In other words, the average for these four numbers is 50. So now we can continue. 45 minus 5. And because we're going to square it, it doesn't matter whether it's positive or negative. 45 minus 5 is 5. 5 squared is 25. This is 55, so this is 25. That's 50, so that's 0, and that's 0. And that's 50. Let's keep that in mind. That's 50. I doubt very much. And since in a standard deviation you have to divide by the number of observations, we're not going to do that because it doesn't matter. B. (10, 30, 30, and 10). Again, the same thing. The mean here, you take away 10 from this guy, 10 from this guy, and give it to this guy, give it to that guy. Now they all become 20. And that's the mean. X minus x. 10 minus 20 is 10. When you square it, it becomes 100. This is 20. 20 minus 10 is 20. 30 minus 10 is 20. 30 minus 20 is 10. When we square it, it becomes 100. This is 100. And that's 100. That's 400. And that was answer choice B so far, which means A is no longer a contender. A was no longer a contender, which we could have seen right away, because in A the data is very clustered, is very close to each other. Let's look at C. 34, 28, 28, and 30. Again, here also we can see they are very close to each other. They are all clustered together. They are not too far spread out. The standard deviation is going to be very low. The average here is again very straightforward. You take a 4 from this guy, give 2 to this guy, and give 2 to this guy. So they are all 30. That's the average. So 34 minus 30 is going to be 4. That's going to be 16 when we square it. The x minus x bar squared. That's 16. That's also a difference of, this is 28 and this is 30. So that's a 4 when we square it. That's a 4. Oh, that was 30. That's 0. As you can see, this thing is nowhere close to 400. And even if I'm being sloppy and if I made a mistake, it doesn't matter, because it's not going to come anywhere close to 400. The answer is not C. So far, B is the contender, B is the winner. Let's look at C. 34, 28, 28, and 30. Oh, that's what we just did. That was C. The one we just finished was C. Let's do B. Oh, we just did D. We did the C also. Let's look at D. 39, 42, 41, and 38. The average is going to be above, it's going to be 40. Take 1 from this guy, give it to this guy. Take 2 from this guy, give it to this guy. You see, it's 40. But again, as you can see, if the average is 40, they're all clustered around 40. They're not too far apart. The standard deviation is going to be very low. So, x minus x bar squared, 31 minus 40 is going to be 1. This is going to be 2 squared. This is going to be 1 squared. This is going to be 2 squared. A 2 squared, 2 squared, 1 squared, and 1 squared does not come anywhere close to 400. As a matter of fact, this answer choice, the one we just did here, this was a D. If the question is asked which one of them has the least standard deviation, the answer would have been D. Since we are looking for the greatest one, the answer is B. That was number 56. That was also the very last one on the page. So we're going to call it a day. Okay? I'll see you tomorrow. Bye now.